right. Let's run through this homework, see how we did with it. Page 287. So, synthetic division, is it okay? Pretty easy. Oh, I'll do whatever ones you'd like to see. Absolutely. 287. All right, so, I'm sorry. All right, so are there, let's see, 12, 14, 16, 18, 20, or 22. This says use synthetic division to find the quotient and the remainder. Is there any from 12 to 22 even that you would like to take a look at? Any from 12 to 22 you'd like to take a look at? Anybody? 22, absolutely. Okay, now, on problem number 22, I will tell you this. I will not test or quiz you on any of these. What we will ask you to use a fraction, but it's a great problem to take a look at. All right, so I'm going to synthetically divide by 1/4. Is that okay? And then I have a 3. I don't have an x cubed term, so I'm going to put a 0. I have a -2. I don't have an x term, so that's a 0. And then I have a 2. Okay? Is everybody okay with how I'm doing that so far? Why am I dividing by positive 1/4 when it was x minus 1/4? Do the opposite. Absolutely. You're setting it that binomial equals 0. All right. Let's work through this, see how we can do. Bring the 3 straight down. 3 times 1/4 is 3/4. Is that okay? 0 added to 3/4 is 3/4. If I were to multiply 3/4 times 1/4, I would wind up with 3/16. Is that right? So then we have to realize that this is actually the same as -32/16. That'd be the same thing as -2. So if I add -32/16, that's supposed to be 2. It's just 2 like that. -32/16 is the same thing as -2. -32 added to 3 is -29/16. Is that right? Now I'm going to multiply -29/16 times 1/4. So I'm going to get -29, and 4 times 16 is 64. Did I do that right? Yeah. I'm going to add those together. So 0 added to that is going to give me this. Oh boy. Then I'm going to take -29/64, and I'm going to multiply that times 1/4, so I get -29 again. 64 times 4. 16, 1, 24, 256. So then you have to realize that 2 is the same thing as 512/256. If I reduce 512/256, I would get 2. And then if I subtract that, let's see, I'm going to get 512 minus 29. What's that? 3, that's 0, that's 4, 10, 3, 433. 433/256. So this is my remainder. And again, I'm not going to give you one that nasty on the test. It'll always be a whole number. What else? For 12 to 22, what else would you like to see? Uh, 24 or 26. Any of those you would like to see? 24 or 26. Any of those you'd like to see? Or 28. Or just 26? Sure. Okay. Can you guys see this okay if the lights are on? Okay, I just want to make sure. 26, they tell us we have function at x, we have 2x to the 4th plus x squared minus 10x plus 1. And then we want to do function at -10, function at -2, or positive 2, excuse me, and function at 3. Okay? So let's use synthetic division on this. We're doing 3 times. So I'm going to use synthetic division with -10 first. So I have 2. I don't have a third term, so I'm going to put a 0 as placeholder. 1x squared minus 10 plus 1. I don't need the plus 1, but that's what it is. Straight down, that's -20, -20, 40, 41, -410, -420, positive 4200, so 4201. Now, 20 times 10. Wow, okay. Sheesh, I don't know what I'm doing wrong these days. It might be heroin, you never know. Boy, I'm going to retry that and see if we can get that right. Okay. 2, -20, 200, 201. Is that right so far? Okay, sorry about that. Negative 2010, negative 2020, and then that becomes positive 20200, so that becomes this. Does that look better? Okay. Some students might say, boy, I just wasted my time doing the synthetic division. Okay? But this is what you actually found with this. The point -10, comma 20,201 is a point that's actually on your graph. So technically you found a point that's on your graph. It's not a 0, but you do have one of the points on your graph. Okay? Let's go with the next. So that one didn't work all that well for us. So now I'm going to take positive 2 and see what happens here. So I have the 2, the 0, the 1, the -10, and the 1. Bring the 2 down. That's 4, 8, 9, 18, 8, 16, 17. So, oh darn, we still didn't show anything. No, we actually found that the point 2, 17 is an actual point on our graph as well. And then last one, we're going to try 3, see if 3 works. Let's see here. 2, 0, 1, -10, and 1. Bring that straight down. That's 2, that's 6, that's 6, that's 18, that's 19. Am I doing that right? 6. Okay. 19 times 3, it's 30. 19 times 3, I can't do it in my head. 257. 47. 47 times 3. Oh my goodness. 2, 120, 141. So that actually tells us that the point 3, 142 is a point. So a little bit nastier of a problem, not horrible to do. The nice thing is synthetic division allows you to do quite a bit of work without having too much in place. That was number 26. So 40 through 44, even. Any of those you'd like to see? 40? Actually, I'm going to do each of those. I'll do all 40, 41, or 40, 42, and 44. So number 40, we have function at x is equal to x to the third plus 5x squared minus 2x minus 24. So if you see 4 terms, the first thing you should think is factor by grouping. Now, it doesn't always have to work that way, but going just with basic algebra. So I'm going to look at those 2. I'm going to look at those 2. I can factor out an x squared. That leaves me x plus 5. And then I can factor out a -2. All right, so if I factor by grouping, we're going to get that. So this is going to tell us flat out that we can't, it won't work. So would somebody do me a favor and graph x to the third plus 5x squared minus 2x minus 24 on a graphing calculator? Somebody graph that and put the cell phones away, please. And the bite key. And then once you have it graphed, hit zoom standard. Sure, good. Somebody graph it on the graphing calculator. Got it? Can you see any place that you think it's going to cross the x-axis? Just give me one of them as a whole number. Yeah, you can go ahead. Or 0. Left side, right side means you'll go above and below the graph. Yeah, I think you're right. I think that 2 works. So I'm going to use the 2. When you look at the graph, it looks like it crosses at 2. It looks like it crosses out to the left as well. So being that it looks like it crosses at 2, what I want to do is I'm going to do synthetic division with the 2. So I have 1, 5, negative 2, negative 24. Bring this down. 1 times 2 is 2. That's 7. That's 14. That's 12. That's 24. That's 0. The 0 there means that this truly, so x minus 2 is one of the binomials of that. Now here's kind of the neat thing about this problem. Now that we've taken this down, I'm going to focus on this part right here. I'm going to plug the x's in, but being I've already divided by one of the factors, I'm going to have it started as x to the third, so I'm going to make this x squared plus 7x plus 12. What 2 numbers multiply together to give me 12, add together to give me 7, 3 and 4. So x plus 3, x plus 4. So this will tell me that the factored form of this is x minus 2, x plus 3, x plus 4. My zeros would be at 2, negative 3, negative 4. The multiplicity of all my zeros is only 1 because it happens only once each time. It doesn't bounce on any of those. So on a test, you would have this kind of problem. If it didn't focus out, you should graph it, see where it definitely crosses the x-axis. Usually it'll be one of the points will work out nicely. That's what we need to go for. Okay. And I said I was going to work out each of these. So number 42. Will somebody graph number 42? I'll put it up on the board. Number 42, we have a function at x is equal to x to the third plus 2x squared minus 13x plus 10. Factoring by grouping is not going to work. So then we have to go to the graphing calculator. Does somebody have where they might think it might cross the x-axis? 1? Okay, so if it crosses at 1, so this is a third degree, so it should look something like that. So I'm going to use 1, and I'm going to see if that works. So I have a lead 1, 2, 3, and 10. Bring this down. 1, 1, 1. It's 1. That's 3. That is 13, isn't it? Is it negative 13? Boy, I tell you. 3, and that should be give us negative 10. And then if I multiply that, that'll give me negative 10. So that's 0. So that 0 means that what binomial does this mean is part of it? X what? X minus 1. Good. So x minus 1 is one of our binomials. I'm going to focus on that. It started out as x to the third, so I'm going to put the x's back in, starting with what? X to the second plus 3x minus 10. What 2 numbers multiply together to give me negative 10, add together to give me positive 3? Do what? 5 and negative 2, so x plus 5, x minus 2. So the whole answer to this problem is going to be x minus 1 in factored form, x plus 5, x minus 2. Will we have a bounce anywhere? No. What's the multiplicity of this? How many times did this one happen? Once. What's the multiplicity of this? What's the multiplicity of that? So my answers are 1, negative 5, and 2 are my solutions to the problem. That's where it crosses the x-axis. The multiplicity of each one, because each one only happened once, is 1. Okay? And then number 44. Number 44. Number 44. Would somebody graph that and tell me where it looks like it might cross the x-axis? If it doesn't cross at a nice place, then negative 3 looks like? Okay, so negative 3 looks like where it crossed the x-axis. So I have 1, negative 3, negative 10, and 24. There's no gaps in there. I don't know if I put 0. Yes?
Isn't there another trick you can do with like with the last digit, 24?
Yes. Take all the factors. That's called Descartes' rule of signs. So what you can do is you take all the factors of 24. So you have 1, 2, 3, 4, 6, 8, 12, and 24. And you can try and synthetically divide each of those. Descartes' rule of signs says this. I went from positive to a negative, negative to a negative, negative to positive. So that means I have 2 sign changes originally without changing any of the problems. So it could cross the x-axis 2 or 0 times if they have real solutions or rational solutions. And then if you plug in negative x, we will hit a small portion of Descartes' rule of signs, not because it's required, but it's actually a neat tool that Descartes came up with prior to any calculators ever being part of it. All right, let's take a look at this problem. But you're absolutely right. That is an absolute trick that will work. Okay, especially in these type of problems. If I make one of these problems up off the cuff, it doesn't have to work. All right, 1 times negative 3 is negative 3. That gives me negative 6. Is that right? That gives me positive 18. That gives me 8. That gives me negative 24. That gives me 0. So what binomial does this yield us?
X plus 3.
Good, x plus 3. Okay, this is what I want to focus on. Our original problem started as x to the 3rd. So what am I going to start with plugging back in here? X squared. What 2 numbers multiply together to give me positive 8, add together to give me negative 6? There you go, negative 4 and negative 2. What's the multiplicity of this? 1, and this yields me a 0 of negative 3. What's the multiplicity of this? 1, and this gives me a 0 of 4. What's the multiplicity of this? Also 1, gives me a multiplicity of 1, and that as an answer. So the true whole answer all factored out is x plus 3, x minus 4, x minus 2. Okay? So, that, guys and girls, is what the homework should have been. I have a sheet here. It's going to be for the review. We do have a quiz on Monday. This particular sheet. Yeah, that's how I roll. Well, being that, Wednesday and Thursday, there's no class, or Thursday and Friday, no class?
Yeah.
Oh, hey, guys and girls, I want to invite you. On Wednesday next week, we will have the med class in the theater. We're having it in the theater. The presentation is done by Dr. Hunt. He was an ER doctor at Swedish when Columbine High School's massacre took place in 1999. It's an unbelievable presentation. I've already invited all the parents of the kids in the class. If you personally would like to join us as well, just come to the theater in the Fine Arts Building. It's at 6 a.m. That's the tough thing.
On what day?
Wednesday next week.
Oh,
It's, you will be here. So, it's it's an unbelievable presentation to realize one, the horrific thing at the event that did take place on April 20th, 1999 was horrible. And I can't make light of it at all, but hearing from the doctor and how his emotions were tied in, he actually left his hospital, showed up at Columbine High School on scene before it was even secure, and was helping victims. And all he really wanted to do was get over to Rock Canyon High School and pick his son up, where his son was going to school. He wanted just to get home and be with his wife and his son. But here he's being a doctor, he's helping victims. I will tell you that the photographs you see are, victims' gunshot wounds. And it's frightening to see, and I pray every day that we don't have to have these tragedies. Unfortunately, they seem to happen more and more often. And the worst thing about when they happen is we're callous to it, it seems like. Oh, geez, I can see that, another one happening. Whereas when Columbine took place, it was frightening beyond belief because something like that had never happened before in that type of condition. And but I'll remind you both Monday and Tuesday next week as well. If you would like to join us in the theater, come as our guest, listen to his presentation. God bless you. Pretty powerful conversation, scary conversation. Pass your homework on in, please. Make sure your name's on it. And this